we're going to go over AWS VPC Fundamentals. And to do that, I put together some terms here that you're going to have to get to know. VPC stands for Virtual Private Cloud, and it's just a way to define a virtual network in the AWS world. And mainly what you have to do is just allocate IP space. And I'll show you kind of how to do that in a bit. Underneath VPCs are all these other components, starting with subnets. Subnet is a subnetwork or a subset of the VPC's IP space, okay? Route table, well, those subnets, they don't actually know how to route traffic unless they're giving rules, and that's the job of the route table. The route table is associated with the subnet, and then it's going to tell the subnet how to route table out to, let's say, the internet. IGW stands for Internet Gateway, and that's the device. There's a highly available device provided at AWS that allows you to route traffic out to the internet. So you associate the Internet Gateway with the route table, and then the route table with the subnet in turn, okay? NAT gateways stands for Network Address Translation, and this is for private subnets. So you can have in AWS private subnets, and with private subnets, basically there's no public IP address associated with that resource. And because of that, it won't be able to talk to the internet. The internet needs to identify that what it's talking to. And that's the job of the NAT gateway. So it's going to take the private IP address of the resource in the private subnet, translate it to its actually own IP address, send that traffic out to the internet, and then the return traffic, when it comes back, the NAT gateway tag that traffic. So it knows, oh, I know you because I sent your traffic out. Then it's going to take that traffic and then translate it back to the private IP address. So that's a NAT gateway, okay? Network ACLs stands for Access Control List, and is a way to define firewall rules kind of at the subnet layer or the subnet level. Security groups is also a way to find firewall rules, except instead of the network layer, it's actually at the resource level, like an EC2 instance RDS database. They're actually very powerful in security groups. Okay, next. So what we're gonna do is we're gonna build up this knowledge piece by piece, starting with the VPC, okay? So the first thing you have to do with VPCs is allocate IP space. And this box represents basically the VPC, and this 10.0.0.0/16 represents about 65,000 IPs. And the best way to explain this is actually a CIDR calculator or subnet calculator, and here's one right here, okay? So I'm going to type in 10.0.0.0/16, hit calculate, and here it says a total number of hosts, 65,000 hosts. So basically, this IP notation right here, or this network IP notation right here, shows that it has 65,000 IP addresses, and the way it works is part of this notation is allocated to the IP space, and the other part is allocated to the network, basically ID. So what you can do is you can have, let's say, more networks, but then smaller IP space, or you can have less networks, but then more IP space. It's a trade-off here, okay? And here, this is 65,000. This is a pretty common one, okay? So that's how we allocated the space here to VPC. And now, under the VPC are subnets now. So you gotta take some of this IP space and then you can allocate it to different subnets. So here, this private subnet is gonna use 8,000 IPs. This public subnet is gonna use 4,000. And then I have another private subnet down here and another public subnet down here. The reason why I have these other subnets is because they're in two different AZs. Here's AZ1 and AZ2. So this is actually an important point with AWS networks. So AZ stands for Availability Zone. Availability Zone is essentially a separate data center with separate power supplies. So let's say a storm comes by and knocks out a data center, it's only going to knock out one AZ. So that means for network design, you have to have at least two AZs. Otherwise, you don't have high availability. Your software can go down if one of the data centers crashes and everything's only happens to be on that same AZ, okay? So that's kind of important. Subnets can be only associated with one AZ, so that's how it's kind of like this. So you could think of like an easy way to think about this is AZs kind of contain subnets, okay? Let's see what else. That looks pretty good. So next slide. This one is just showing space IP allocation once again, just in another form, just to drive home the point that the VPC has 65,000 IPs here. It starts at this private subnet here at 10.0.0.0/19. So let's actually throw this in the subnet calculator actually now. Hit calculate, and you can see this is 8,000 IPs. It starts right here, okay? That's exactly what we see. And then the next basically IP space is going to start at 32. How do I know that? You click forward right here on this calculator. It's pretty neat. And then now it's 10.0.32. See? All right. And then for that, I actually use the /20. And the reason I use the /20 is just because usually people by design, they design smaller This is only 4,000. They design smaller public subnets and bigger bigger private subnets because you have more resources that are generally private. So that would be like, let's say, EC2 instance here, and then public subnets would be, let's say, like a load balancer. So you probably have less load balancers than you have EC2 instances. Okay. All right. So this is another way to understand how IP kind of space allocation works with VPCs. Okay. So what we've done so far is allocated IP space, but we haven't actually set up like routing rules yet. So let's say an EC2 instance that lives in this public subnet doesn't know how to talk to the world. It's lonely, okay? In order for it to reach the internet, you have to set up a route table. And then the route table, you have to associate with the subnet and then define a rule that says route basically in outbound traffic going to the internet through this route table, through the internet gateway, and then it can go to the world and then all the way back. Okay. By definition, if you associate internet gateway with the route table, it makes it a public route table by definition, okay? So now these two route tables, or these two subnets, resources in the last subnet, can now go out and talk to the internet. But how about these two other subnets right here, the private subnet 1 and private subnet 2? They're lonely, they can't escape. There's nothing routing them out. So on top of that, they're private subnets, so that means resources here are not going to have basically IP addresses associated with them. And even if you do associate an IP address with them, they're not going to be able to get out because the network itself is not going to allow it. The subnet is not going to allow it. So how do you get around that? NATs. So that's what network address translation is, okay? So you set up another basically route table here. There's a private route table. You associate that with a private subnet. That goes to the NAT. That NAT actually lives in a public subnet because it needs a public IP address to go through this here, right here. Right? Only devices with public IP addresses can go through the internet gateway and talk to the internet. So that's basically the full route path right here. The trace goes from private subnet here through the private route table, through the NAT. Okay, the NAT would then take that private IP address, assign it its own public IP address, and then route all the way to the internet. The internet sees it as the NAT's IP address. Then the return traffic comes back to the NAT. The NAT has already tagged that traffic. Then it goes all the way back to the private subnet here, okay? Okay, next is the network ACL. I haven't talked about that yet, okay? So there's another component still here, yeah. So there's the network ACL, and that's essentially kind of like a firewall rules at the subnet layer or subnet level. So you see this network ACL is associated with this private subnet, this one also associated right here with this public subnet, and also with this one. So I'm just using the default network ACL. When you create VPCs, it's always going to create a default network ACL. You can create other network ACLs too and associate and override that kind of. But a lot of people just use the default because then you have one kind of stop measure. If you want to block and deny all traffic, which you can do, you can use deny rules with ACLs. You can deny it at the network ACL layer, and then that denies everything instead of looping through all your network ACLs associated with the VPC, okay? So that's why people usually do it this way. And now we're going to go through the network trace with the network ACL. So let's say you have a EC2 instance here on the private subnet 1. It first goes through to the network ACL. The network ACL has to allow it to go out, and by default it does, okay? But you can always add deny rules, okay? Then it goes through the private route table because it still doesn't know the route. This is just handling basically permissions. This is handling route, and it says, hey, I'm going to direct you to NAT. So it goes to this NAT right here, and this NAT here then goes to the network ACL actually again because that's associated with this public subnet right here. Then it goes to the public route table, then internet gateway, then out to the world, and all the way back. Now I will point out again, there's a NAT here, and there's a NAT here, okay? So there are two NATs and two different AZs because let's say this AZ goes out, and you only designed your network so it only goes through to one NAT, you just basically lost internet connectivity to your entire network, okay? So that's why you have more than one NAT usually. But there's a cost associated with NATs, and that's why some people will actually forego the NAT and forego private subnets because NATs cost $72 currently per month. And if you have two of them, that's $144 a month, okay? I'm sure prices are gonna change, okay? But that's just so you have an idea. Okay, so that also covers now network ACLs, and then I just made a note about NATs and how you should have them on different AZs by design there, okay? Now security groups, finally introducing security groups. So security groups don't operate at the subnet level or the network component level. It operates at the resource level, EC2 instance RDS database here. So here's security group 1, security group 2. So you can think about this as kind of security layers. So for basically traffic to escape all the way out to the internet from the EC2 instance, it has to go through security group, then it has to go through a network ACL, Then has to be routed to the internet, and then it can go through the internet gateway and then finally go to its destination and then come back. Okay, so these are just separate layers, and depending on your needs, some people might need a layer at the network level, and some people are okay with security groups. And security groups, like I said, are very powerful because you can associate them directly with the resource. You see, network ACLs, you have to define the rule, and it applies to every single resource in that subnet, so you don't have fine-grained control there. Okay. So now we're ready to complete the picture. This is the full VPC picture now, okay, with all the IP addresses and everything. So here's 65,000 IP addresses. Of those IP addresses, 8,000 are allocated to this private subnet and 8,000 are to this one. Then there's 4,000 allocated to public subnet because there's less public, usually public resources than there are private resources. And then there's 4,000 over here too. And let's trace it all the way now. So here's the EC2 instance with the security group that has to allow traffic out. It goes to the network ACL. Then the private route table tells it, hey, go to a NAT because I don't have a public IP address. Then it goes back to the ACL, and then it goes to a public route table here that then tells it to go to internet gateway. Now the route from, let's say, a resource that resides in the public subnet is much more simple. It just goes from the EC2 instance to the security group to the network ASL to the public route table, internet gateway, out to internet, and then it's done. Okay, and then it goes back that path too. Okay, but that's pretty much it. So that covers some essentials or VPC fundamentals that are very kind of important to kind of getting started with VPCs. It's just a lot of bit of work, so I will recommend actually building VPCs a couple times over, and then you hopefully that will actually help you kind of learn and understand VPCs fully. Okay, thanks.